Problem number 10, I want to find the reference angle in each case. The reference angle is always acute. It's the angle between the terminal side and the x-axis when you've drawn the angle in standard position. The hint here says to draw a quick picture. 7 pi over 6, hopefully you've got that in your head as 210 degrees. I can figure that out pretty fast too. 180 divided by 6 is 30 times 7 is 210. 210 is 30 degrees past 180, and you see there's my answer right there, because the reference angle is the angle between the acute angle between the terminal side and the x-axis. We went 30 degrees past, and so my reference angle is 30 degrees. 3 pi over 4. 3 pi over 4, the memorized value there is 135 degrees, which is here in the second quadrant. Again, I could remember that quickly. 180 divided by 4 is 45 times 3 is 135. The reference angle would be this angle, the acute angle, so something between 0 and 90, between the terminal side and the x-axis. 135 is 45 degrees short of 180, and so the reference angle would be 45 degrees. And then finally, negative pi over 3. Pi over 3 is 60, so negative pi over 3 would be approximately here. And in this case, this is the reference angle. The reference angle is always positive because it's acute. It's just a measurement. It doesn't include a direction. Well, we know exactly how much that is. It's just 60 degrees. So the reference angle here would be 60 degrees. One great pattern: anytime the denominator here is a 6, the reference angle will be 30. If it's a 4, you'll have a 45, and if it's a 3, you'll have 60. Problem number 11, find the distance from each point to the origin, to 0, 0. Again, a picture is probably helpful. This one is very easy. 0, negative 4 is just down here, and I can see very clearly that it would simply take me 1, 2, 3, 4 spaces to walk that particular distance. So the distance would be 4 units. Of course, if I'm not on one of the axes, like in this one, then I'm going to have to do a bit of calculating. Negative 3 comma 4 would be right here. My question is, how long is this? Well, I'm not going to be able to measure that directly, but if I drop a perpendicular from my point down to the x-axis, I can represent the negative 3 as this length, and I can represent the 4 as this length, and then I realize the d, what I want, is simply the hypotenuse of this right triangle. So just use the Pythagorean theorem. Negative 3 squared plus 4 squared equals d squared. That's 9 plus 16, which makes 25. And so, of course, when I square root each side, I'm just going to get d equals 5. Letter C should work out similarly. I've got the point 2 comma 5, something like this. I can drop that perpendicular, form that right triangle. This is 2, this is 5, d would be the hypotenuse, so the math is going to be very similar here. 2 squared and 5 squared is going to be d squared. 2 squared is 4, and 5 squared is 25. I'm going to get 4 plus 25, which is 29, and square root each side. I don't have any way to simplify this time, and I did just want the exact simplified answer, so final answer is simply the square root of 29. Problem number 12, just a quick reminder, 0 divided by any number is 0. Of course, a number divided by itself, 1 divided by 1, is equal to 1. And a number divided by 0 is one of those mathematical impossibilities. You can't divide by 0, and so we say here this is undefined. Problem 13, we've got a 45, 45, 90 triangle here. The sides always come in the ratios x, x, and x squared to 2. I'm just trying to fill out the basic versions though, and so I'll use 1 for the legs, meaning the hypotenuse is just square root of 2. Then I've got a 30, 60, 90. I know 30 is the smallest angle, 60 the medium, 90 is the largest. The simplest version here is 1 for the shortest, root 3 for the medium side, and then 2 for the hypotenuse. The ratios of a 30, 60, 90 always follow x, x root 3, and 2x. Problem number 14, using those pictures, we can calculate these trig ratios. So secant of 30 degrees. Let's see, 30 degrees is found in this picture. Secant is related to cosine. So I think I'll determine the cosine ratio first, and then I can reciprocate it to get the secant ratio. Cosine is adjacent, here would be the adjacent leg, divided by 2 the hypotenuse. That's cosine, square root of 3 over 2. Well, that means secant is the reciprocal of that, which would be 2 divided by square root of 3. I do want to simplify, which means I'll need to rationalize, and I end up here with 2 root 3 over 3. Letter B, cotangent 45. I guess I can use either 45 degrees in this picture. Cotangent is the reciprocal of tangent. Tangent is opposite, so 1 over adjacent, which would be 1. That's 1 over 1. Well, cotangent is just the reciprocal of that, but turning 1 over 1 upside down still leaves you with 1 over 1, which simplifies to just be 1. And then sine of 60 degrees, so I'll have to use this angle here. Sine is opposite. This side is opposite the 60 degrees, divided by 2 the hypotenuse, opposite over hypotenuse. Sine is square root of 3 over 2 then. Notice that for the 60 degrees, the root 3 was the opposite leg, whereas for the 30 degrees, the root 3 was the adjacent leg. So you have to think about which angle you're using. Problem number 15, we want to draw a quick graph of the line y equals negative 2x. I suppose an easy way to do this would simply be to make a table. When x is 0, negative 2 times 0 is also 0. When x is 1, negative 2 times 1 is negative 2. When x is 2, you're going to get negative 4. If I simply plot these points and connect the dots, I'll have my line. Of course, I could have also used the fact that the slope of this line, the number in front of the x, is negative 2. So once I had one point, all I have to do then is go down 2 and over 1, down 2 and over 1, etc. to find more points on the line, or alternatively up 2 and left 1, up 2 and left 1, and so on. And you can see here we've got all these dots that are in a straight line. Connect the dots and we have our line.